looking at a picture of a chemical fertilizer. Nitrogen-based fertilizers help sustain food production for billions of people around the world, and this wouldn't have happened without its building block, the wonder molecule ammonia. What are some of the forces that hold this molecule together? Let us learn about that and much more in this video. We know that bond formation between two atoms takes place either by the transfer of electrons, as in the case of magnesium oxide forming an ionic bond, or by the sharing of electrons, as in the case of oxygen, resulting in a covalent bond. The chemical compounds having covalent bonds are called covalent compounds. In this topic, we will study the formation of some of these covalent compounds. Let us begin by building a water molecule. A water molecule is composed of two hydrogen atoms and one oxygen atom. Both the hydrogen atoms need an electron each to complete the duplet configuration, while the oxygen atom needs two. Thus, the three atoms mutually share their electrons such that both the hydrogen atoms acquire a stable duplet and the oxygen atom acquires a stable octet configuration. As only one electron pair is shared on both sides, the water molecule has two single covalent bonds. Next, we shall build a molecule of ammonia that comprises one nitrogen and three hydrogen atoms. Each of these atoms requires more electrons to gain stability. This leads to mutual sharing of electrons, resulting in an ammonia molecule. Here again, three single covalent bonds are formed between the atoms. Diamond, an allotrope of carbon. In the structure of a diamond, the electronic configuration of the carbon atom is 2, 4, and its outermost shell is short of 4 electrons to obtain a neon-like configuration. Therefore, each carbon atom combines with 4 other carbon atoms to attain stability and thus forms the giant covalent structure of a diamond. Let us now study some of the properties of covalent compounds. Physical state. Covalent compounds are generally liquids or gases at room temperature. However, some of the covalent compounds like glucose and sucrose are solids. Solubility. Polar covalent compounds like ammonia, in which there are partial positive and negative charges in the molecule, are soluble in water. However, non-polar covalent compounds like naphthalene remain insoluble in water. Melting points and boiling points. Molecules of a covalent compound such as water are held together by relatively weak forces as compared to the ionic compounds such as sodium chloride, which possess strong bonds. Therefore, melting points and boiling points of covalent compounds are low, as less energy is required to overcome these weaker forces. To summarize, we have studied the formation of a few covalent compounds like water and ammonia and a few of their properties. Covalent compounds are generally liquids or gases at room temperature. Polar covalent compounds like ammonia, in which there are partial positive and negative charges in the molecule, are soluble in water. However, non-polar covalent compounds like naphthalene remain insoluble in water. Molecules of a covalent compound such as water are held together by relatively weak forces. Diamonds are precious. Their hardness and high dispersion of light makes them unique and also useful in industries and jewelry. But did you know that diamond is essentially a form of carbon? Wait for the upcoming videos to know more about